Okay, horizontally launched projectile. So, okay, so this is an object that's launched horizontally. It has a horizontal velocity of 15 meters per second. It's at a height of 25 meters. So we want time in the air, final vertical velocity, and range. All right, so just a refresher, to get time in the air, we use this equation, which is on your equation sheet. We're starting vertically from rest because we're not moving in this direction initially. So this is always going to be 0. And then we solve this for time. This is where we end up with this equation. And I would go back and refresh on that if I needed to, because that we use this equation a lot. It comes from this. You can also put numbers into this, like that's up to you, okay? But to get time in the air, we're using this equation again, so we have 2 times 25, that's our height. That's what dy is, that's our vertical displacement or our height, divided by 9.8 for g. And so that's going to give me, let's see, okay, 50 divided by 9.8 is 5.1, and then I want to take the square root of, what did I say, 5.1? Merp. I get 2.25, so 2.3 seconds. Okay. To get our final vertical velocity, okay, what we do here is we use another one of our equations. We're really using this one. This is our acceleration equals final velocity minus initial divided by time. I'm using g here because this is an object in free fall, so that's the acceleration it's going to have. This is 0 because we're starting from rest. So in order to get my final vertical velocity, I'm going to end up with g times t. I'm just solving this for final vertical velocity. This is 0. Okay. And think about it as it's been in the air for this amount of time, and for every second of that time, it is accelerating by 9.8 meters per second. Each second. So if I multiply 9.8 meters per second by 2.3 seconds, I'm going to get how fast it's going, and this is like right before it hits the ground. Okay. So when I multiply 2.3 and 9.8, I get 22 meters per second. So that's how fast it's going, because every second it's been speeding up by 9.8 meters per second. Then the range, this is my horizontal displacement. So like this is my range. Remember we calculated that, we did labs on that. And that depends on my horizontal velocity times time. That's a constant velocity equation because horizontally it's a constant velocity. There's no horizontal force. So 15, and that was a given here for my horizontal velocity, times 2.3 gives me 15 times 2.3. No, hang on. 2.3 equals 34.5. Hopefully that's right. 34.5 meters. So it's going to land 34.5 meters from this base of this height that it was launched from. Okay, we'll draw horizontal and vertical velocity vectors. So remember, my horizontal velocity is constant, so it's just going to be that same 15 meters per second. And then vertically, I start at 0, and then I begin speeding up as soon as I'm in the air every second I'm going to be, draw that one a little longer, speeding up by 9.8 meters per second. So my vertical velocity vectors are getting bigger, my horizontal staying the same. Okay. What's the acceleration of the object after it's launched? My acceleration vertically is 9.8 meters per second per second. It's my same as g. In the x direction, I don't have any. I have a constant velocity. Okay. I have this constant velocity. But in the y direction, I'm speeding up every second by 9.8 meters per second because gravity's acting on me.